So welcome everyone. My name is Frédéric Passeron and I'm part of the HP Dev team, and along with some of my colleagues in the name of Denis Choucroun and Didier Lally, we are very happy to see you in this summer session of the HP Developer Community Meetups. Today our host will be Owen Garrett from Deepfence, and he'll be presenting finding vulnerabilities in production with open source ThreatMapper. So I have to go through a very few housekeeping items before we start, and then I'll be leaving the stage to Owen in a few minutes. So before we start, okay, here we go. Please move to the next slide now. Okay, this one probably. As I said, a few housekeeping items. So, well, obviously, the meetups is a new monthly series that we've introduced this year. These are in-depth and I would say, given in-depth meetups or in-depth sessions on a specific technology, usually focusing on open source development and DevOps and this type of subjects, I would say. The other, I would say, skill-up activity that we can provide you with is the mention learn, and these are, I would say, more industry agnostic subjects that have been covered. So you'll be hearing about experts talking about or sharing their ideas or leadership insights on popular HP and open source technologies. So obviously, Denis will be kind enough to share the links within the chat. In the chat, so you will see the calendars for each of them. You'll get the registration links as well as the replay links for all the sessions that have occurred in the past and that you might have missed and that you'd be willing to look after. And so these are all available on our hpdev.io website. Okay. Workshops on demand. So if you're not familiar with this activity, keep in mind that these are free hands-on experience workshops that are available to you. They're available 24/7 all year long. There are around 27 or maybe more of them, out of which 19 of them are open source. So it could be Git, it could be Jupyter itself, it could be Python and other subjects. So give it a try, provide the feedbacks in the conclusion notebook of each of the workshops. There is a server link, and we'll be very happy to hear from you, and you can provide some insights on what you'd like to be seen in the forthcoming months as far as workshops are concerned in this survey. Well, the developer community is a community, and we need you to contribute and amplify, without which the community would not live that long, I would say. So we'll be very happy to have you to join and invite others to join our talks, whether they be meetups or dev talks. We'll be happy to see many of you as well to join our monthly newsletter, in which you'll be finding all the relevant information about the program itself, all the latest and greatest blogs that have been written, the latest platform information that we've been adding to the website, the latest workshops that have been done, and so on and so forth. There are many Slack channels, and the one that we're looking at is the Slack hpdev.io one, and we'll be happy to see you there as well, asking questions about the program and asking questions about other channels that might be relevant to you in terms of interacting from a programmatic standpoint with our developers. You can follow us on Twitter, and you can also write a blog. So if you look at the URL that shows that probably Denis has pasted in the chat, you'll see how to contribute with us. And it's very simple. We have a CMS in place, and the process of writing and getting the blog to be reviewed and published is quite easy. You can somehow end up in the place of Owen at one point of time and deliver meetups if you feel like there is a subject that you would like to propose and that you feel is relevant to the community. We'll be very happy to welcome you there. And obviously, if you're willing to work with me and give and provide a new workshops on demand, I'll be very happy to work with you as well. With that being said, I think we've got everything ready. So the last thing you need to know is the QR code, and everything will be summarized in this in the link that you might get to using the QR code. With that being said, I will leave it to you now, Owen, and the stage is all yours.
So, Fred, thank you very much for the introduction. I'm really excited to be part of the HP developer community. I work with an open source company called Deepfence. We are open source first. I'll talk about the products in a little bit. And I look after our product roadmap and on our community activities. And I'm really excited today to join you again on a Munch and Learn technology talk. We spoke last year. We ran a session together on microservices and networking and ingress and service mesh. Today, we're going to take a different topic. We're going to look at the security of cloud native applications and how you can use open source technology, specifically Deepfence ThreatMapper, to hunt down and find threats and vulnerabilities in those applications and improve your security posture. Very happy to take questions, and please share them in the chat. I may not have time to grab them as we talk, but we'll take time at the end to go through. Deepfence, as I mentioned, is an open source company. And our core open source product is one called ThreatMapper. You'll find it on GitHub. It is genuinely 100% open source. There are no hidden away features. There are no limits and scans. There's no privacy concerns around phone homes. And just as the HPE community has a very vibrant Slack workspace, we too have a vibrant Slack workspace where you can connect and meet with the Deepfence engineers, talk about strategies for deploying our open source solutions, not just ThreatMapper, but solutions for finding vulnerabilities and threats in a range of different forms, capturing networking traffic and examining that traffic. So vibrant community, very, very keen that you become a part of it. Let's talk about what it is that the challenge that the Deepfence technology addresses. When I talk to our community and our users, I very commonly find out that there is a gulf of understanding and a gulf of working together between the engineering team, who have a great set of tools for scanning for vulnerabilities, for identifying issues within cloud native applications as they're built and as they get staged for production. But then the gap comes when we talk to the operations teams, the SecOps teams, the app security teams, the network ops teams, who say that they are using tools such as WAFs, cloud workload protection platforms, cloud native application protection platforms, things like that, great acronyms, all generating huge numbers of alerts, but without the context of the application. And this challenge causes a lot of friction within organizations. I don't know if this is something that you identify with, something you find it hard to bridge the gap between the language that the engineering team and dev team talk, the tools that they use, and then the language and tools that are used on the other side by the SecOps teams. Deepfence exists to help you address and solve some of these problems, to close the gap. A little bit of background, because you may not have heard of Deepfence, although the company has been around for a couple of years. We really took off late last year with our first open source release, with the ThreatMapper project. And we sit in an emerging space, which we call security observability. The mantra is that if you want to unify the development and DevOps perspective of the application and the environment with the SecOps view, then you need to have tools that can observe what's happening, identify threats, and provide security with a common language and a common tool set. So we'll see what that means in practice shortly. We are open source first. We launched our runtime threat analysis project, ThreatMapper, in October of last year, and that's the project that I'm going to spend time sharing with you today, talking about how you can find what is the risks of vulnerabilities in production, and then how you can track those down so you know what to fix first. Of course, we also have a commercial arm or commercial activities to the business. There's no point having an open source company if there's no way of sustaining those open source activities. And so we support the open source work that we do with enterprise editions that provide runtime protection for threats and vulnerabilities that our open source platform may have discovered. So what can we help you with? We'll delve into the problems very briefly, but to set the scene, our open source technology is here to help you understand what are the outstanding threats within your production environments, particularly around cloud native environments, so cloud-based, Kubernetes-based microservice applications. So what are the threats and how do those threats pose a risk to your business? Which of those threats that our tooling has detected are most significant, have the highest risk of exploit, and which you need to then direct back to your engineering or DevOps teams in order to remediate. As we go through, you'll see that the key visualization that we give you, the key message, is the concept of an attack path. How might an attacker locate and then exploit particular threats that we have discovered within your production infrastructure? And the enterprise product, which I shan't spend any more time on in this session, provides a second tier of protection. So where threats have been discovered and it's not possible to address those threats immediately, our enterprise product exists to then track how attackers may be trying to exploit those threats, and it steps in and protects those threats from being exploited when it identifies an attack in progress. As I said, you'll find Deepfence's open source technology on GitHub. The key project to begin with is Deepfence ThreatMapper. Please, after this session, if you're interested in finding out more, take a look. As I go through this session, in the demo, we'll go through installing ThreatMapper pretty much from scratch and querying and monitoring a running production infrastructure. So you'll have a good grounding on how to get started with ThreatMapper after this session. But you'll find other open source projects from Deepfence, tooling to scan container images and file systems for secrets, tooling for scanning the same containers and file systems for evidence of malware with our Radar project, and tooling for capturing network traffic across distributed environments, and then using machine learning to classify those network flows and gain insights. So let's talk about vulnerabilities and threats in production applications. And as I talk about vulnerabilities, I'm going to be talking specifically about supply chain issues. The applications that we build are built on enormous stacks of open source technology, pulling in hundreds or even thousands of third-party open source modules. And the concern at the top of most application security teams is how can we be sure that these applications are secure, that they haven't pulled in packages with known vulnerabilities. And there's a great set of tooling to help developers do exactly that, to scan applications during the build process, at test time, when they're staged to go into production, and to match the SBOM, the software bill of materials, against a range of different public vulnerability feeds, CVEs, security announcements, data from GitHub, and the like. So the first question that you may ask is, when I'm thinking about the threats that may be hidden within my application, my developers assure me that they use tools like Claire or Sneak in order to scan applications for vulnerabilities as they're built and before they're deployed. Is that enough to then identify and protect me against the risk of those vulnerabilities, being exploited? But what we know is that to do that really is only solving half of the problem, half of the way that vulnerabilities can find their way into your application and potentially be exploited. Vulnerabilities are commonly published by way of CVEs. About 50 a day last year were published. There's a fire hose of alerts. There's multiple other sources as well. And it is common, there's no blame attached. It is common for open source stacks, libraries, packages to be found to have vulnerabilities. And the teams scramble to fix those vulnerabilities as quickly as possible. As I say, there is no implication of blame there. It's a fast-moving world with very complex, rich, open source tooling that allows us to build applications extremely quickly. But with that, inevitably comes the risk that vulnerabilities will occur and teams have to scramble to fix those. The problem we have is that vulnerabilities can be found at any point within a piece of code. They aren't found just after the code is published and the first time it's been used. On average, and GitHub's own surveys of the components that are hosted on the GitHub platform show that on average it takes about 4 years between publishing a piece of code and identifying that there is a vulnerability in that code. Vulnerabilities can be extremely subtle. Even once a vulnerability has found for a mature in production software library or extension or component, on average, again, based on GitHub data, it takes about 12 weeks to identify the nature of the vulnerability, to fix it, to publish a fix, to alert users of an upgrade, and to push the fixed version out. So that gives attackers a significant window to try and exploit a vulnerability that has been found. But more importantly, it means that organizations who scan code for vulnerabilities before it's pushed into production then are significantly exposed because unknown vulnerabilities can be found at any point after a component has been deployed. And at that point, the development team has probably moved on. Their responsibility for shift left initiatives has been refocused onto other projects, other tools that they're building, other pieces of code that they're writing. This application with a now vulnerable component is found in production, and it falls to somebody else to understand and triage this vulnerability. A great example of this, so a real example that hit us very, very hard late last year, was a vulnerability found in the Apache Log4j module. I'm sure you're all aware, many of you have probably been intimately involved in patching this module, patching your applications late last year. The code that introduced this vulnerability was pushed out into the tree in 2013. So it's about 8 years old. It was pushed out. It was pushed out as the 2.0 branch was being written. 2.0 was declared production ready in 2014, and 1.0 and its successors were end of life a year afterwards. So for the last 6 to 8 years, organizations and third parties building Java applications that require logging have typically selected Log4j, and they've been including code that later on was discovered to be vulnerable. The code was extremely well-intentioned. The patch that was introduced was there to help particularly complex enterprise users configure and manage their logging behavior to a very, very fine degree. It involved pulling a Java module from a third-party location, the intention being the enterprise would write this Java module that was then pulled into the logging code at runtime, and it was used to shape how the logging functioned. But what wasn't anticipated until 2016 was that it might be possible for a malicious user to try and subvert that process of pulling in a third-party module and somehow commit an RCE, a remote code execution, within the Log4j module in the application. This was first speculated about in 2016, and it really took speed late in 2011, so early November 2011, where a thread on GitHub postulated that an attack could exploit this functionality, an attack that came to be known as Log4j shell. Proof of concept was shared in late November of last year, and the very first exploit was seen in production a week after that. This vulnerability was particularly pernicious because it worked in two stages. In the first stage, an attacker could remotely probe systems, typically HTTP endpoints, send requests with JNDI tags of various types of encoding, and those requests would cause vulnerable implementations of log4j to call out to an IP address of the attacker's choosing. So effectively, they act like a beacon. An attacker could spray the internet with requests using a variety of different techniques to try and find their way through firewalls and encoding, and wait for a successful request to then launch a beacon back to a web server on an IP that the attacker controls. Now, having done that, the attacker would then find a way to remotely deploy a Java module on the target system. And the first instance of that, the first exploit that used that, was used to deploy crypto miners. Not really a surprise in the current situation. Crypto miners on target systems, stealing CPU resources, but also potentially exposing, showing that those instances were subject to other types of attack as well. The community, of course, scrambled as quickly as they could to fix this issue. And again, when we look at things like Apache struts, we look at log4j, we look at other types of high-profile issues which are exploited by code and assumptions deep within a software capability. It can take several attempts, several steps to try and fully understand the nature of the issue, how widespread it is, how easy it can be exploited, and push fixes out. It took, looking here over, it took about 3 or 4 weeks of attempts to first disable the feature, remove it, and then through further investigation, discover additional vectors for a remote code execution, the denial of service, and other remote code executions. So you saw earlier on the explanation that it can take multiple weeks to identify and patch. This is a great example in case. So it took, in this case, again, a little over 4 years, so I think about 6 years in this case, 8 years to discover. It took a number of weeks to remediate, but we're all still living with the consequences of this vulnerability. And we all know that there are still instances of applications running in production, instances that we have built and shipped to customers and clients that may well have this vulnerable code and may well be exposed to this kind of attack. This is the nature of software vulnerabilities in a complex, interconnected world of open source tooling and software. So given that just scanning code when you build it, satisfying yourself there are no known vulnerabilities at build time, and then shipping to production, given that that falls far short of catching long-term issues like log4j and other software vulnerabilities, what else can we do? There are great processes and toolings in place to audit and log the software, the SBOM, software bill of materials for applications. And I know of a number of our users who are using tooling that captures these SBOMs and archives it, tagging those, mapping those against running applications. The logic being that you can then scan the SBOMs on a regular basis, matching those against up-to-date vulnerability feeds. And if you find a new match because a new vulnerability has been disclosed, then you can work backwards and quickly identify the running applications that have those vulnerable components and then take remedial actions. Is that sufficient in order to help have a secure security posture that protects you from threats and vulnerabilities? And it is to an extent. But applications are extremely complex. Things change fast. Processes for tracking SBOMs may not be fully accurate or fully followed. And finally, what you run in production is often very different, highly extended from what you pushed, what you staged to go into production. Components that run in production can be sourced from multiple places, not just components that you've built yourself and put in a staging repository, but third-party container images and third-party applications may be running within production. At deployment stage, for example, with mutable admission controllers, those components may be modified. Your ops team may want to inject agents and various integrations in order to add in logging or visibility or metrics tools into production workloads. They may have additional policies that extend or change those workloads by adding integrations. If you're using a sidecar, if you're using a service mesh or other kinds of technologies, you may find that those inject sidecars into production workloads. And finally, the platform itself that you run on, whether it's bare metal, virtual machine instances, or even something provided by your cloud provider, those components may also have packages that haven't gone through your SBOM interrogation stage. So you are somewhat blind to vulnerabilities that are published, which may be present within those components. So what you're running in production deviates significantly from what you think what your developers believe they have built and scanned and staged for production. So it's this blind spot, this gap between development, understanding the vulnerabilities in development, and having a clear idea of what they're shipping, the gap between that and our production team, who are at the end of a fire hose of alerts from a range of different tools and are struggling to map those back to what it is that the developer pushed into production and understand what is the risk associated with those alerts. And that's what at Deepfence we want to help you solve. We want to help you better understand the gap between development and production. The pristine, near perfect code that your developers may have built, free of all known vulnerabilities, and the messy runtime environment that your platform ops and SecOps teams are trying to stay on top of. They want to shift left, moving further into development. The developers need to have perspective to help them look to the right. And it's bringing these two perspectives together that we can help you address with the technology at Deepfence. So let's move on and let's have a little look at this technology in action. We'll look at Deepfence ThreatMapper. I showed you the GitHub repo, so we'll begin from there. And what I'm going to try and do in our demo today is deploy ThreatMapper from an initial state and then connect to a couple of running production environments. And we'll look at how we can scan those and identify issues running in those environments. ThreatMapper is made up of a couple of components. You can find the documentation here on our README. And what I will do, first of all, is I will deploy the key component, which is our management console. I'm going to deploy that on a Docker host, this machine here. So freshly installed, nothing running. And we grab Docker Compose file, and then we're going to run Docker Compose, and that will stand this management console up. In a production environment, you may want to deploy this management console on a dedicated Kubernetes cluster instead. And we have tooling for that as well. Docker is great for a single server, a single host, a way to get started and start experimenting. But as I mentioned, Kubernetes is probably what you'll want to use in a production environment. And installation of Kubernetes is slightly more complex, but once again, achieved with the Helm chart and easy to manage, easy to upgrade, and full documentation for managing this within the ThreatMapper documentation. The console takes a couple of seconds to start up, so allow 30 seconds or so. If I try and load this now, it may, so it's not quite ready yet. If we have a little look at what is going on, so if we look at the router process, okay, so it started now. So it works, it has built into the product are a series of liveness probes. So we look and wait for the individual components on the product. So the various databases, Elasticsearch, for example, to initialize itself and start up. Once that's running, then the router's up and running. And now the router's up and running, we can connect to the management console. This is a brand new install. So there are no accounts registered. The very first user who comes to this install will register. And once I have registered, then no one else is able to register through this exposed portal. Instead, they are invited using a process here for inviting users to the management console. Now, if we look at the management console, there's nothing to see because we've set up the console, we haven't set up yet the agents. The agents run on our production systems and they phone home, they talk back to our management console and provide telemetry. Here, I've got a Docker host running a couple of containers, and I'm going to take my Docker installation process and I'm going to paste that in. So we'll pull in the Deepfence agent container, we'll start it up, we'll give that a moment to get going. This agent, whoops, didn't mean to do that. This agent talks back to our management console, which I have running at this address. It uses a shared secret in order to authenticate itself. And it runs as the listener on our Docker host in order to identify what processes, what containers are running, capture traffic, and run scans. I also have a Kubernetes environment. So I will install the agent on that environment as well. So if we look at what's running there. So just as on our Docker environment, we had a few workloads running here on our Kubernetes environment. We've got a number of workloads running. The agent is installed using a Helm chart, making it easy to manage and update. So having installed the chart, we'll then install a release, once again, using a shared key in order to authenticate back to the management console. And the agent runs as a daemon set on our Kubernetes cluster. Runs in its own namespace, completely separate. This is everything that you needed to do in order now to deploy the agents, which then phone back to our management console and start providing telemetry. So now we've identified, we have a Kubernetes cluster that's just spun up, and we have workloads running here on a DigitalOcean cloud in Amsterdam. This is the host, this is the Docker host that I mentioned earlier on. It's running a couple of Docker containers, as you saw earlier. Those containers, okay, so the agent is now collecting network traffic. So we see we have incoming traffic coming from the internet to an SSH service. So that's my login. We have traffic hitting an Nginx worker process and then hitting a Java service. So that's our application running the Java service owned by the log4j container. And what I'll do is I will start a scan on that log4j container. So we don't know what's running in that container. So I'll do a vulnerability scan. I'll also kick off a secret scan. And here we're looking for threats that may be present in that container. And just for good measure, I'll scan a couple other containers as well. So we'll look at the Nginx proxy. So we'll run a scan on that and start a secret scan. ThreatMapper, through the agent, pulls in a range of metadata and telemetry to help us understand what's running. So this container image, we now know the image name, the command within that, the ports that it's listening on. We can look at the Java process and get additional metadata around there, where traffic is coming from. While we're letting those scans run, it looks like one of them is finished. We'll come back to that shortly. We can also query our Kubernetes environment. So once again, this is a production system hosting a number of workloads, pods, and Kubernetes. And to shortcut things, I'm going to pick one of the Kubernetes nodes. I'm going to scan everything on that node, and I'll tell ThreatMapper to scan the entire cluster. So this will tell the agents running on each of the Kubernetes nodes to trigger off scans. They will scan both the container images for vulnerabilities within the pods. They will also scan the host operating system that those nodes are running. So we get a full perspective of what's going on on those Kubernetes nodes. So we've fired off a series of scans, and these scans are running in a production infrastructure. We made no significant changes to the production infrastructure other than to install the lightweight agents that you saw. And these scans sit and run in the background, sending back SBOMs, so bills of material for what they have found on those systems, both in the containers and on the hosts. And those SBOMs are then matched against vulnerability feeds that ThreatMapper sources dynamically from a range of different providers. We publish vulnerability feeds from MITRE, CVEs, from the National Vulnerability Database. We take vulnerability feeds from a number of different operating system vendors, so Red Hat, Debian, Alpine, and the others, of vulnerable packages that they publish. And we take a number of different GitHub security advisory feeds as well. These individual third-party feeds are themselves made up sourced from a number of other feeds. So this gives us extremely good coverage to understand what are the potentially vulnerable components running in our production environment. As I said, these scans sit and run in the background, gathering SBOM information and reporting back. And let's have a little look at some of the vulnerability scans that have run. So far, we've got results back from the 2 containers running in Docker. So the Log4j one and the Nginx proxy one. You'll remember I kicked off a Kubernetes scan. That'll probably take a little bit longer to run, but eventually you'll see that data appearing here as well. And if we look at the container image, so this is one that was picked because it deliberately exposes the Log4j vulnerabilities and others. We can look at the vulnerabilities that we have detected on this running container. They're sourced, as I mentioned, from CVEs and other locations. And you can see we've picked up 101 critical vulnerabilities on this container, over 600 vulnerabilities in total. Published through the SBOM, different components that we have discovered on that. We can click in and look at an individual vulnerability. So here we have something that is marked as a critical vulnerability relating to tar. This one can be exploited if an attacker is able to find a way of triggering tar with user-defined input, and the attacker can use that to create privileged files, setuid or setgid. So it's marked as a high vulnerability. In this case, it's not been fixed because it is a behavior of tar that can't easily be removed. So although it's a long-term vulnerability, and we have plenty of data around it, it's exposed, and it's something which you would need to look at and maybe decide that your application is not vulnerable to that. So you could then decide that you want to mask that vulnerability. You don't want that reported any further. But if we look through this huge range of security vulnerabilities, if we go through, we will probably find at some point, pages maybe 3 or 4, we may find the Log4j issue flagged up somewhere. We'll find other vulnerabilities that you'll need to go through. There's Log4j. With traditional vulnerability management tools, you then are faced with this enormous list of vulnerabilities, and it's up to you to manually triage these vulnerabilities and identify which of these are potentially risky and what can you do to address them. We go a good bit further than that. So rather than just providing you with a list of vulnerabilities and leaving it to you to figure out what's going on, let's have a look at our vulnerability scans and see, okay, we're beginning to get data fed back now from host scans and container images as well. So this is data that comes back from our Kubernetes cluster. But what ThreatMapper does that helps you interpret and understand these vulnerabilities is that we then visualize them for you using a ThreatMapper concept of an attack path. So here we have identified and ranked what we feel are the vulnerabilities that pose the greatest risk of exploit in your application. So we have picked up vulnerabilities with high severity. So critical severity, they have an attack vector of network, So an attacker could potentially exploit that vulnerability without local access. We prioritize vulnerabilities that are present on workloads that are currently handling live network traffic. We rank at the very top vulnerabilities where there's a known exploit for that vulnerability. And then we plot that using this graph visualization, the attack path. We don't just limit ourselves to workloads that are directly connected to the internet. As you saw on the topology, we're able to track network traffic through workloads to other workloads. So here, for example, we find vulnerabilities on our log4j application, which we know is sitting behind an Nginx proxy, which in itself is receiving traffic from the internet. So this intelligent calculation helps you triage and identify which of the vulnerabilities present within your applications pose the greatest risk of being exploited, and shows you in real concrete terms how an attacker might look to exploit that vulnerability. I talked about vulnerabilities as one of the threats that your application may be faced. You'll remember we also ran secret scans. Another threat that you'll find is that applications, container images, or file systems can be pushed into production with sensitive data that should have been scrubbed still remaining on the production system. For example, your development process may put an AWS token onto the file system so that the development tests can run and use that token to identify themselves to internal systems in order to perform suitable tests. But you may forget to remove that token when the system is then pushed into production. The fear then is that if an attacker is able to compromise that system when it's running in production, they could obtain sensitive information like AWS tokens or details from etc. password that is greater than the principle of least privilege, the limited capabilities you want to put into those production systems. So as well as looking for vulnerable components on production, we can also look at vulnerable data that could relate to potential secrets. Just as some vulnerabilities cannot be fixed or have to be there because the functionality is necessary, a lot of the secrets that we will detect are presented to you as warnings to let you know you have etc. password, you have a private key, you have other data on that host, and you can then go through and review that data and determine, is this a false positive? Is this sensitive information that needs to be on the host? It has to have that particular authentication key, or perhaps inadvertently sensitive data that is of too high sensitivity has leaked through and found its way on that host, and you need to step in and address that. We're all about finding threats on workloads that are running in production, but you can also use ThreatMapper to perform the same scans against workloads that are staged in registries. I could go and add a registry in Docker Hub. So let's take the MySQL registry. Let's put that in. Let's just pop in my credentials for Docker Hub. So I can then connect ThreatMapper to a range of different registries, not just Docker Hub, but GitLab and Key and Amazon ECR and the likes, and see registries that I have connected to. It takes a couple of seconds to scan that registry. We found a series of images here, a MySQL server with various tags. We could pick one of those and I could schedule a vulnerability scan on that image. And that can sit and repeat itself in the background. And when alerts happen, we can then integrate this with a range of different messaging systems, notification systems like Slack or Teams or an HTTP endpoint, pushing alert information to different sources, raising tickets, archiving data for long-term offline storage, or generating pretty reports to share up the team to provide information about vulnerabilities sitting within production. But if we come back and let's look finally at what's going on our environment, we have the topology chart that ThreatMapper gives you that's derived from the agents that we've deployed. You can explore that topology chart either graphically, or if it gets a little bit complex, through a tabular interface, or using our API to identify workloads within that. You can delve in, look at the services, you can see scans that are running, images that are running, the results of vulnerability scans. We can then look in detail at this, go say hello, for example, and get a quick low list of the vulnerabilities present on that. But most importantly, and if there's one thing to take away from this, most importantly is the ability to stack rank vulnerabilities so that you and your engineering teams know what to fix first. Vulnerabilities, as we saw, are a fact of life. They happen, they can't be avoided, and what matters is how you respond when those vulnerabilities and threats are discovered. And that's what we're here to help you with. With ThreatMapper open source, we're here to help you understand what's in production, to scan that for vulnerabilities, exposed secrets, and other kinds of threats, and then determine how you wish to respond to that. Who uses it? As I said, it's been out, although it's based on a mature code base, it's been available for production deployments for about 10 months. We have a growing number of GitHub stars and a number of users who have connected with us. So just a sample on the left-hand side, showing people who've connected us through Slack or other ways who are using ThreatMapper in production. And it's a project which we're actively developing, working with the community to build out additional features. Our vision for ThreatMapper is that it becomes a central point for identifying threats of all types within your production platforms, whether those threats are vulnerable components, whether they're exposed secrets, or, as is coming in a future release, and I'll give you a very quick preview of what you'll see in ThreatMapper open source in the next major release, whether those are configuration errors. Here, this is a staging system, and the posture capability that I'll show you is capability that's going to come into open source in due course. We found vulnerabilities, we found exposed secrets, but wouldn't it be great if you could also find compliance issues? So those are typically misconfigurations or weak configurations of your production environment. We'll have the ability to scan production environments using the APIs that those environments present, or doing on-host scans for operating systems in order to identify compliance issues. In our development builds, we can scan through AWS, we can do Kubernetes, we can run scans directly on individual hosts to look for common Linux misconfigurations. But if you look at AWS, what sort of mistakes might be made on an AWS production system? Those mistakes could be on any one of a number of different AWS objects. You might have misconfigured S3 buckets. You might have weak permissions on CloudWatch. You may have errors with other types of AWS configuration. And we'll be bringing to our community the ability to scan these individual services and identify weak configurations. So having looked at the inventory, let's look at some of the scan results. Here's a scan that we ran recently. And once again, this is development code. It's not production ready. It's not polished. It's not fully complete. So there's still work which we're doing to improve the usability and the quality of the data that we present. But here, we executed a CIS benchmark against a limited AWS environment, and it flagged up 87 potential alarm issues. Let's look at our VPC, drill in on that. What have we found? 9 tests, 6 alarms. If we look at one of these, so we have the concept of a security group in a VPC. The recommendation for the default security group is that it doesn't allow any ingress traffic. So it denies all inbound traffic and allows outbound traffic. The reason for that is a security group, a default security group is attached to new resources. And the problem that the reason this has been flagged up as an alert is that in our compliance tests, we found that some of the a named default security group has both inbound and outbound rules. So these are the additional kinds of threats that we're looking to help you discover in your production environments. Map these out with the attack path in order to understand how those threats can be exploited, give you a true way of understanding the security posture and the threat graph that you're facing. So we're here to help you be secure. We're here through our open source capabilities to help you understand what's running in your open source environment, in your production environment, looking at the dependencies, the operating system configuration, and the cloud and Kubernetes infrastructure of your production environment to help you understand, are your assets secure? And then rank any insecurities or failures for secure assets against our estimation of their risk of exploit. As you saw, you can run ThreatMapper against your deployment environments, so your staging registries. You can use ThreatMapper within your CI/CD pipeline, so you can use it in a development environment as well. But frankly, there are other much better suited tools to run there. You got to use a range of tools in order to give you good security coverage. And with ThreatMapper, we're here to help secure as broad a range as possible in your production environment. So, find out more, please come and take a little look. First place to begin would be GitHub. Go to the Deepfence ThreatMapper project. I showed you how straightforward it is to install ThreatMapper in a local Docker environment, to run the console, and then stand up the individual agents or sensors on Docker or Kubernetes environments. Get started there. Please give us a star. Stars are our key metric to understand and demonstrate the success and the relevance of the project. So we greatly value stars for the ThreatMapper project. Come and talk to us. Join us on the community Slack. If you have any questions, any challenges running ThreatMapper, or want to talk about new features, new capabilities, you'll find us in Slack. Use ThreatMapper, hide the blind spots that you may currently have on your production infrastructure. So that's what I'd like to share with you. Deepfence, open source, we are developing solutions around the security observability space to help you understand better what's running in your production environment. Use Shift Left using great tools like Snyk and Tenable. We help you secure the production system. So let's take a break there. I'm really happy to take any questions or any thoughts or follow-up. So, Fred, let me hand back to you.
Yeah, there are actually a few questions that were risen during your presentation. One coming from Bruno Kornek, and he was mentioning that SBOM somehow are a bad way to measure vulnerabilities. Sorry, my spelling is very bad today. When it comes to Linux distribution, for instance, Red Hat keep the same version, just bumping the release tag when fixing a security issue. How are you dealing with this?
Yeah, that's a really, really good point, Bruno. The reason, so I mentioned that we pull threat feeds, so vulnerability lists from a range of different sources. We pull in the CVEs, we pull in Red Hat security announcements, ones from Oracle, ones from other vendors, and we pull in the GitHub security announcements as well. That gives us very broad coverage. So if a vulnerability is present, there is a very, very high probability that we will be able to identify that and match that against the particular system. But it can cause false positives. So in the example that you gave, Bruno, where Red Hat may not do the best job of updating the package so that it's now known as being secure, we do everything we can to help you understand that. So if we look, I'm just picking one of these at random, we give you all of the metadata we can. So the package that caused the issue, where it is. We give you links to CVEs. We give you the fixed data. So you can look and you can determine for yourself whether this is a vulnerability that you're concerned about, or perhaps is one that you want to mask off because it's a false positive. So again, you can select that vulnerability and you can choose to mask that vulnerability so it's not seen again.
Okay, there was a second question, but I think the answer you already provided was, does it run actually on Windows-based system in the ThreatMapper? So I saw that you were dealing with Azure, but I mean, if we talk, the question was probably to the host level. Would you be able to leverage some vulnerabilities on the host, on a Windows host itself?
So the vulnerability scanning and detection is done using the Deepfence agent, which is deployed in your production systems. We have an experimental agent for Windows. We don't judge it as being production ready. So if you'd like to try it on a Windows host, we'd be more than happy to share the code with you. But it's not something which we recommend in production at this point. There's too many differences between the Windows architecture and the Linux architecture.
Okay, thanks a lot. And finally, there is a question from Geoff. Can you please clarify the authentication and permissions for the agent? For instance, did you set up remote privilege root passwordless access to do these scans? Or is it a good idea? Is that a good idea in production?
Yeah, really good question, Jeff. It's something that a lot of users rightly raise as a question against the architecture that we use. When you look at security products like ThreatMapper, they operate in one of two different ways. They can operate in an agentless fashion, where they talk to the APIs on the platform that's running, and then they're able to make security calculations based on what they can see through the APIs. The cloud posture management capability that I previewed for you is exactly that. It's agentless, it talks to the APIs. But there's also things that you cannot see through the APIs. You cannot see live network traffic. You can't see the host file system and scan that for vulnerabilities or secrets. And so some of the capability within ThreatMapper, by necessity, is implemented using an agent that runs directly on the host, and yes, needs to have sufficient permissions that it can identify network flows and query the file systems for containers and the host file system. That's a necessary evil. And that does create questions about the security of the agent. Our agent is open source. It's been pen tested. I'm very happy to share the pen test results with anyone who's interested. And it's architected in a way that follows good security practices. It doesn't listen for any kind of traffic, for any kind of ports. It phones back to the management console over TLS with authentication, and it listens for basic instructions from the management console. The library, the capabilities that it has are as limited as possible to minimize the attack surface. The agent does very little calculation itself. It simply gathers data in a read-only fashion and forwards that to the management console, where the calculations, the vulnerability scans, and the like are performed. And that way, being fully aware of the concerns about root level agents and production systems, we've architected it to have as secure a security posture as is possible.
Okay. In the meantime, I stood up the poll. So for all the attendees, if you take a second, if you don't mind, it's just a few questions on the session itself, and we'll be very happy if you can answer them. So I will leave it open till everybody's got a chance to participate. With that being said, I mean, I would like to thank you again, Owen. Great session. I think it was really, really interesting. I learned a lot, so I really appreciated it. If there are any other questions, we still have 1 or 2 minutes left, so feel free to use the Q&A in Zoom. Or, I mean, I don't know if you can unmute yourself, but still the Q&A is the best way, and I'll be relaying the questions, if any. With that being said, hopefully there are still many people who didn't do the poll yet, so I will leave it open for some more time. And thanks, yeah, again for the session and the demo. That was really interesting. I think, yeah, the security issues or question about the agents is always something that comes along at this type of, of sessions, I'm pretty sure. And how much of a, in terms of performance, how greedy, can I say, is the agent itself? Because I saw on the documentation, it was like talking about a few CPUs that were needed to actually get the agent running properly. So how, depending on the infrastructure you'll be dealing with, how much of a, I mean, is like one agent for a large single Kubernetes cluster, or would you need more than one in a case of really large setup? Or
sure, yeah, sure, Fred. So the agent runs per node. So its visibility only goes as far as the host that it's running on. So in a Kubernetes environment, you deploy the agent using a daemon set. And that ensures that the agent is running on every single node in your Kubernetes environment. In terms of resource usage, the agent has a couple of functions. In the background, it polls network flows, so it can share back the telemetry that we saw if we have a little look on topology graph. So you get an idea of the telemetry. So that is provided by the agent, and it shares on demand. It performs SBOM and secret gathering. So the background load of the agent is extremely light. It'll be less than 1% of your CPU utilization. The on-demand work, again, is pretty light. It's short-term. It's a quick discovery and post back to the management console. So we don't see any issues around the resource required by the agent. The console needs a reasonable bit of resource in order to do the calculations, but that's something you keep yourself in your own environment. Okay.
Thanks for answering. Okay, so I think we reached the end of the session, and I got like 86% of participation to the poll. So I would say that's quite good for now. And so I will thank you again, Owen, and thank all the participants, and wishing you a very good end of your day and summer breaks, if any are coming soon for any participant. And our next session will take place probably next month, I'm pretty sure, and I'm sure that Didier will make some communication around it and send some invitation fairly soon about it, as he came back from vacation now. He'll be having time to achieve this. So with that being said, I will thank you all, and I think we can close the call, and wishing you a very good end of the day. Bye-bye.
Great. Thank you, folks. Thanks, guys.
Welcome.